Greetings from the Hermitage, and welcome to this presentation on solving equations using only multiplication or division. Some examples of the equations that we'll be working on are these. The first one, 3x equals 12. And whenever we solve that equation, what we're looking for is that value of x. This is a multiplication problem. Next one is x divided by 6 equals 4. Once again, what we're looking for is the value of x that makes this equation true. And finally, a combination multiplication division problem. 3 times x divided by 7 equals 6. And as always, what we're looking for is that value of x. And as we work through these equations to solve for x, our final goal is to get 1x equals whatever the answer is for each of these equations. These equations are a little bit easier to solve if we first review some 6th grade math. In particular, we're looking at how to multiply two fractions, two rational numbers. And if you recall, to multiply two fractions, we multiply the numerators just straight across like this. 2 times 5 would be 10. And then we multiply the denominators. And in this case, that would be 3 times 7. If I remember correctly, that's 21. So in general, whenever you're multiplying two fractions, let's say you have a over b times c over d, you would get a times c over b times d. Fractions don't get any easier than that. Let's move on to the next slide. There's a secret to solving these multiplication division problems, and we'll review that right now. The real secret is how to get a coefficient of 1 on the x. Everything else is pretty easy, but this is fairly new to you if you're in the 8th or 9th grade. But to change a fraction like 3/5 into a 1, we just multiply by the reciprocal. The reciprocal means just flip this number over. The 5 would go into the numerator, the 3 would go into the denominator, and then we multiply using the rule for multiplying fractions, and that would give us 15 over 15 equals 1. In general, to turn a number into 1 in these equations, we multiply by the reciprocal. The reciprocal of a divided by b is b divided by a, and that equals 1. This is called the multiplicative inverse. That inverse word means simply to turn the fraction upside down, and then we multiply. Let's look at a couple of examples now. From the first or second slide in this presentation, we had 3x equals 12. It's very easy for me to get disorganized, so I always do little things to help myself stay organized. And since we're working with fractions in this case, I'm going to go ahead and write everything in this equation as a fraction or as a ratio. To start off on this one, I'm just going to put a 1 here and a 1 here. I've divided both sides by 1. Doesn't change anything. All it does is help me stay organized. Now, right now I have 3x equals 12. Really what I want is 1x equals something. I don't know yet what that is. But now I'm going to multiply both sides of this equation by 1 over 3. That's the reciprocal of 3 over 1. So this is going to be 1 over 3 here. And now we have, on the right-hand side of the equation, we have 12 divided by 1 times 1/3. This is an expression of the multiplicative inverse. Whenever we employ the multiplicative inverse, that automatically gives us 1. So now we have 1x equals 12 divided by 3. I can factor 12 into 3 times 4, and that's still divided by 3. And 3 divided by 3 is 1. So now we have x equals 4. Go ahead and box that answer in. Let's check our answer. We're going to do a check on it. All we have to do is take that value of x and put it back into the original equation right here. So that's going to be 3 times x equals 12. Put the 4 in there. It's going to be 3 times 4 equals 12. We have 12 equals 12, and that's a check. Our answer is correct. We got this identity. If we got something other than that identity, then our answer 4 would have been incorrect. But since it solved this equation, since it gave us the proper answer, our derivation was correct. Example number 2. This is a division. Once again, since I'm only working with multiplication and division in these equations, I'm going to make everything look like a fraction or a ratio. Now I have x divided by 6. I don't want x divided by 6. I want 1x equals something. To get this 1 here, I multiply this. This is actually 1 over 6. I'm going to multiply that by 6 over 1. And to maintain my equality, I have to multiply this side by 6 over 1. This is my multiplicative identity. That gives me a 1 automatically. So now I have 1x equals, and now we're going to multiply the fractions. Remember that we just multiply straight across. 4 times 6 is 24. That's over 1. Any number divided by 1 is the same number, so that's going to be 24. Our final answer then, x equals 24. We'll box that in to show that that's our answer. We'll do a check on that. We'll take this value of x and put it back into the original equation. The original equation was x divided by 6 equals 4. Take this 24 right here, replace this x with the 24, we'll have 24 divided by 6 equals 4. And we know that 24 divided by 6 is 4 times 6 divided by 4. Pardon me, that's not exactly what I wanted. This was going to be 6. The 6 divide out and we have 4 equals 4. That's a check. The work that we did over here then is correct. Finally, example number 3, and this is where the multiplicative inverse really comes in handy. We can save ourselves a few steps by multiplying this 3 over 7 by 7 over 3. That's the reciprocal. What we're doing here is a multiplicative inverse. We have to multiply both sides of the equation by 7 over 3. Whenever we use the multiplicative inverse here, that gives us a 1x. And now we have 6 times 7 divided by 3. That equals 3 times 2 times 7 divided by 3. The 3's cancel out, and we have x equals 14. Let's do our check. We'll take this value of x and put back into the original equation. The original equation was 3 times x divided by 7 equals 6. Replace the x by 14. Now 14 is the same thing as 2 times 7. The 7's cancel out. Now we have 3 times 2 equals 6. And that's a check. That means that all the work that we did over here is correct. If we got anything other than this identity, other than 6 equals 6, then we would have done something wrong, and you'd have to go back and find the mistake. So in summary, whenever we have an equation like 3x equals 18, our goal is to get 1x equals whatever that answer may be. And to change this 3 into a 1, we use the multiplicative inverse. I personally always make everything into a rational number by putting a 1 in the denominator. And then I multiply that 3 over 1 by 1 over 3. That's the multiplicative inverse. We have to multiply both sides by 1 over 3. We know by that property, the multiplicative inverse, that's automatically 1. So I have 1x equals 18 over 1 times 1 over 3. That's going to equal 3 times 6 times 1 divided by 3 times 1. The 3's cancel, the 1's cancel, and our answer would be 6. At that point, we would go ahead and do the check. But to save ourselves a little bit of time in this presentation, we won't do that. But you should always do it whenever you're doing these problems. And finally, we did a little review of 6th grade math fractions. In general, if you multiply two fractions, a over b times, let's say, c over d, to multiply the fractions, you just multiply the numerators. It's going to be a times c, and then you multiply the denominators and keep them in the denominator. It's going to be b times d. So that pretty much wraps it up for equations involving just multiplication and division. And at the end of the day, there's only one thing left to say, and that is, that's all, folks. Thanks for learning, thanks for listening, thanks for watching. Be safe, con cuidado.